face because it is a square pyramid. And this is a slant edge. It has, how many slant edges it has? It has 4 slant edges. This is the base, and this is the edge of the base, which has 4 sides again, which will all be equal, and the corner of the base, they will be having 4 corners, so it becomes a square pyramid. And these are the dimensional parameters of a square pyramid. The next thing that comes is that sections of solid. Now in this 6th chapter we have 2 things. One is the projection of solid, the next one is section of solid. So in this introduction, we are having this introduction today, so we are going to study that what is a section. Now there are 2 types of sections basically. One is known as a section of solid, and the other one is known as a frustum of solid, which will be there in the other slide. Now when we call it a section, we have a plane which basically cuts the cone or cylinder or pyramid or prism into from a particular point. And as you can see, say we'll assume this as the cone, and in the cone I'm inserting, or I'm cutting the cone at any angle using a plane, and hence I receive this surface when I remove the upper surface. If you remember, when we were studying construction of curves, or when we were studying engineering curves, we had this ellipse that we obtained by cutting the cone into by using a plane. So this is a similar thing that is there. I'm sorry. Yeah, this is a similar thing that is there. I cut the cone at, say, height h on the left hand side, and height say h1 on right hand side at, say, angle of 30 degrees. So I have this ellipse that I have received. So this is the section of a cone when I am cutting it with that plane. Now this section cannot be parallel to this base. Now if it is parallel, then it won't be an ellipse, and it will be classified into frustum of solid. So hence, if we are talking about section, then it should make any angle with the base, and it should not be parallel to the base. The top and the base should not be parallel to each other. That is after cutting it with a plane. Similarly, this is a cylinder. Now the cylinder has a circular base, but its top has been cut by some angle, so we have a ellipse at the top and a circle at the base, and they both are also not parallel. Then the next thing that comes is that we are having say this is a pyramid, a square pyramid, which has a square at the bottom, but we have cut it at a varied angle. So we have this as a trapezium, which is there, which is formed on the top of the pyramid, that is there on your screen right now, which is there behind my cursor. So these are examples of sections of solid. Now these orange parts are basically shown to show the inner part of any solid, that what does it basically contain. So this is shown by hashing of lines, but here I have shown it as color so that you can view it rather more easily than if I have shown hatching. Okay, next, as I said, was frustum of solid. Now you can observe that in the previous slide and in this slide, the only difference is that here again I am taking a square pyramid and a cone. Now I have cut them with a plane which is exactly parallel to their bases. So what I'll have is that in this pyramid, we know that the cross section keeps on decreasing, and finally we reach at a point where there is no cross section and there is only a point, that is a tip. So say if I cut this square pyramid at height h, so I will again height h with a plane which is parallel to the base. So I will have again a square, but this square will be smaller in dimension with related to the base square, but it will be parallel to the base. So this is the difference between section of solids and frustum of solid. Again, if I take a look at the cone, again I am cutting it with a plane which is exactly parallel to the base. So what is happening is that when I cut the cone and I remove the upper part, what I can see is that orange part. That orange part is also a circle, but it has radius less than what the base circle has. So this is known as frustum of solid. I hope you all got the classification. So now let's move on to projection. Now before projection, as we always do, we'll just go through the briefs of what the coordinate, what is the coordinate system, what are the different views, and where a particular view is formed when the object is located where. So if an object is located in the first quadrant, then where it is formed, in the second quadrant, then where it is formed. So first we'll look at that, what are the different type of planes that we are going to encounter. There are three principal planes that we are going to use. One is the horizontal plane, one is the vertical plane, and one is the profile plane. Okay, after that, the next thing comes is there are three types of views that we can make of any object. If it is if it is two dimensional, or if it is two dimensional, or if it is a three dimensional, or it is one dimensional. As we did it with line, as we did it with plane, now we are going to do the same thing with solid. We are going to make its front view, we are going to make its top view, and we can also make the side view whenever we want. So the front view is formed on vertical plane, that is known as elevation. The top view is formed on horizontal plane, that is the plan, and the side view is formed on the profile plane, which is known as side view itself. Okay, the next thing that comes along is the different quadrants. We have 4 quadrants which are marked in anti-clockwise direction, as on your seen on your screen. First quadrant, second quadrant, third quadrant, and fourth quadrant. These are basically formed by x and y axis intersecting at the origin. So we have formed first to fourth quadrant. So now let's see this in an isometric view. So these are the 4 quadrants, and here it is denoted that the top view is formed on HP and the front view is formed on VP. And if it goes in other quadrant, then this will be VP and this will be HP. So front view will be there itself, and top view will be here. And similarly with third and fourth quadrant as well, the things will change. Now the main part, that where the position will be located. Now it is exactly the same as the line and exactly same as the plane. Solid will also, if it is located in front of HP, above HP and in front of VP, then the projection, we can say that the solid is in the first quadrant. And if it is located above HP and behind VP, then it is in the second quadrant. If it is below HP and behind VP, then it is in the third quadrant. And if it is below HP and in front of VP, then it is in the fourth quadrant. So now we have all the basics. We have known what are solids, what are different types of solid. We have studied classifications of solid. So let's start solving some examples. So today we'll be solving 3 examples. In these examples, we'll be encountering 3 different solids. And in these 3 different solids, all these solids would be having its axis parallel to one of the planes and perpendicular to the other. Suppose if we take a cone, we'll take up a pyramid, and that pyramid axis, it's if it is parallel to say VP and perpendicular to HP, and in other cases we'll have some axis which will be perpendicular to VP and parallel to HP. So, and again I am saying what I always say before we start solving questions, that before solving any problems, you should always read the questions very carefully, because the data should be noted down very accurately. If you are not noting down the data accurately, and if you are not interpreting the problem perfectly, then your solution itself from the start is wrong and you will not get the marks. So it is very important to dedicate time in exam to reading the problem rather than just looking at the problem and doing the solution, because at the later stage you might encounter a line which says the problem is totally reverse of what solution you are drawing. So you should read the whole problem and interpret it first, and then only start making the solution of the problem. Okay, now let's read the first problem of projection of solid. Here we having a hexagonal prism. Now hexagonal prism, we have a side of base 25 mm and height of 45 mm, and it is said that it is resting on HP with one of its edges of the base parallel to VP. The axis of the prism is parallel and 35 mm away from VP. Draw the projection of the prism. Now what it is basically saying, let's interpret it into an isometric view of the problem first. So I have this VP and I have this HP. Now I'm assuming it in the first quadrant because no data is given to me. The thing is that I'm having a hexagonal prism. Now that hexagonal prism is say you can see on the screen that this line is parallel to this, that is xy, and we can say that it is parallel to the plane VP. This I'm talking about this side of the hexagon is parallel to VP. So I have satisfied the condition which says the one of the edges of the prism should be parallel to VP. So this is there. Now another thing that is given in the question is that the base is there on HP and it is available here, and we can say that this we are having the axis here and it is say 35 mm away from VP. So this is this distance between VP and the center of this hexagon is 35 mm. So let's start drawing the prism. So first of all, we'll need to know that where will our top view and where will our front view be located. Now take a look at this figure and just see that if I'm looking from here, from where this institute logo is there, I'm looking from here. So this the way my cursor is going is my front view, and if I see it from where figure is, then this is my top view. Now the front view will be there on HP and the top view will be there on front view will be there on VP and the top view will be there on HP. So if I have this I'll keep it other way. Yeah, if I have this kind of a thing, this is there, this is my the object is in the first quadrant. Now if I just open it and if I make it share like this, if I just it is there. Okay, it is reverse on the screen, so let's make it this way. Now it is there in the first quadrant. Now what happened is I'll just make it straight, so I'll have my VP above and HP below, and below in between I'll be having a line XY. So I will have my front view above XY and I will have the top view below XY. That is always the case in when we are talking about object in first quadrant. So now let's come to the paper and the pen and let's start drawing what we want in this question. Now we have a hexagonal prism of base 25 mm and a height 45 mm and it is resting on HP. So I know the top view would be a hexagon that is given in the question. So first I'll be drawing that hexagon, and then I'll be drawing the front view of the this prism that we have. So first I'll draw my line XY. X, Y. So this is there. Now what I have to do is I have to mark a point which is 35 mm away from this line XY. Why 35 mm? Because it is said in the question. If you look at the question, I'll keep it there for you. Yeah, it is there on your screen. Now it is said in the question the axis of the prism, you can see here, the axis of the prism is parallel to and 35 mm away from VP. So I know if it is parallel to VP, then it will be perpendicular to HP. Now so I have to take the distance from HP. So it is 35 mm, so that is 3.5 centimeters. So I'll take it on the center. I'll mark this point. I'll mark this point as O. This is the center of my hexagon that I have. Okay, now what I'm going to do is I'm going to draw a hexagon. I'm going to draw it with freehand, but you have to make it exactly how it is used by using a circle and cutting the different arcs on the circle and measuring it. And we know what will be the angle. 360 divided by 6. Why 6? Because it is a hexagon, hence we'll be dividing 360, that is the total degrees of any of a circle, into 6 parts. So we have 360 degrees divided by 6, which is equal to 60 degrees. So all the exterior angles of the hexagon would be 60 degrees. Okay, so I will draw it freehand. Now another thing that is given to me is that this can be considered as VP when we are drawing HP. So one of the side has to be parallel to what? It has to be parallel to this VP. So first of all, what I'll do is I'll draw this side which is parallel to VP. Okay, I'll use a scale, but I'll be drawing it freehand. And the side which is it is given is it is 25 mm, means 2.5 centimeters. So this is a bit bigger than that. Okay, this is 2.5 centimeters. I've taken this at 2.5 centimeters. Now what I'll do is, again on the both sides, until the this is 2.5 centimeters, again 2.5 centimeters, 2.5 centimeters, 2.5 centimeters, and 2.5 centimeters. Okay, and I'll mark this as, I'll use other color. This is 25 mm. Okay, so this is there, and also the distance of the center. This is my center, so the distance from here is 35 mm. Fine. Now what I have to do next is that I have to extend my projectors. First of all, I'll mark them. I will say start from here and I'll mark them A1. This is B2, C3, D4, E5 and F6. So I marked all the edges, that is, this is A1, this is B2, this is C3, this is D4, this is E5 and this is F6. Now I'm going to extend the projectors of this, all the points on line XY. First of all, so let's take this. I will have both these points, that is B2 and F6, on same line. So this is one point. Again C3 and E5 will be on same line, and D4 will have one line. So I have this point and this point will be in same line, this point and this point will be in same line when we are drawing it exactly up to dimensions. So this is there. Now it has been said to me that it is there, it is resting on HP. So when I am looking it from the front, say if this is the pyramid that I am talking about and this is the tip of the base and it is resting on HP, so when I am looking at the front, then the base is exactly on there. So if it is there on XY line itself, so the height is 45 mm. So this tip that is there, this tip that my finger is there, this will be exactly 45 mm away from this XY. So my height of 45 mm will exactly start from XY. So when I